Hello, good morning. So the first lesson of this week is on the ambiguous case for sine law. Before I start to show you the different cases of how to identify the ambiguous cases, I would like to remind everyone, okay, that in any given triangles like this, triangles ABC, the longest sine length is always across from the biggest angles. Okay, so as you can see here, the biggest angles I have C here, and the opposite sine length C should be the longer sine length. Okay, and the shorter sine length should always across from the smallest angle. So in my example here, angle A should be the smallest. So therefore, the opposite sine length, length A, should be the shortest. Okay, in terms of sines. Now, even though we will have all kinds of triangle, like the equilateral triangle, the isosceles triangle, or the right angle triangles, but I don't want you to worry about like what kind of triangle should I be start drawing it. So for the purpose of testing for the ambiguous case, this is the kind of triangle that I always want people to do. Okay, so it's like you take a long line and a shorter line, and then you enclose the triangle. So this is the type of triangle that I always want you to start with. Okay, and then from the this is what I call the draft triangle. So once you have a draft one, and then put in the informations, and then you can come up with the accurate one later on. Okay, so let's get started to how to test for the ambiguous cases. Basically, there are two main types. The first type is we are dealing with the acute triangles. So acute triangles means all interior angles they are less than 90. Okay, and of course, then the other type, type B, is when we are dealing with the obtuse triangles, when we have one of the angles, one of the interior angles that is greater than 90 degrees. So we will be talking about that the other case later on. But let's start looking into the acute triangle first. Okay, so first I draw myself a draft triangle like this. Again, long, short, and then I enclose it. And I would usually label my my vertices with the capital letter A, B, and C, and then I will have the small letter A, length B, and length C that is across from each of the angle like that. So we should all know how to label our triangle. But keep in mind that we don't always get a triangle that's always called ABC. So later on, you will be seeing some of the example that we might have triangles XYZ, triangle RST, and so on and so forth. But the general rule that how we label the triangles is according to the capital letter for angles and small letter for the sine length. Okay, now the case one under the acute triangles. So we are looking into the sine length A, and to see if the sine length A is equal to the height of the triangle. Okay, if yes, then that means we are getting a right angle triangle. So let's go back to take a look at my draft triangles up here. The height of the triangle is coming from the vertex of the triangles and all the way down to the base of the triangle and form the 90-degree angle. So this is going to be my the height of the triangle here. And with this height here, then you can see that I'm going to get two right angle triangles, one bigger one over here on the left side and one smaller one on the right hand side. If we're looking at the smaller right angle triangles over here, because this is where the length A is happening, and if we're comparing to the length of A and with the length of the height, and if the length of the A is exactly equal to the height, then that means so this line must be the same as this. That means then I wouldn't have two right angle triangles. Then I will end it up with a triangle that like this, because usually on the right angle triangle, the length A will be my hypotenuse length. And hypotenuse length should be the longer side length in any of the right angle triangles. So theoretically, A should be greater than the H. Okay? So if you have a case where the A is equal to the H, that means there's only one triangle here, but this is also a right triangle. Okay? So in order for us to find the height of the triangles, we usually will take the sine of this angle using the trig ratio. Sine of the angle A should equal to the opposite side length, which is the H, and divided by the hypotenuse. So if we're looking at the right angle triangles on the left side, so if I want to determine what the height is, then all you have to do is take the sine of this angle, A, equal to the opposite, so H, divided by the hypotenuse, which is the B, okay? So solving for H, so this is the formula here, that I always take this length B times the sine of an angle A, okay? So same thing, even though I redraw this triangle, when I know that the A is equal to H, I still do the same thing. How do I determine the height or the length A? Is by taking the sine of A, sine of angle A, equal to H divided by the hypotenuse length B. Okay, so this is the formula. So giving you the showing you the example, something like giving an angle A equal to 30 degrees and the length A of 24. Okay, and then another length B of a 48 cm. Now, I want you to pay attention to the kind of questions that we are going to get here. Usually you will get unknown pairs. Okay, so what is unknown pairs? Well, unknown pair is when you know the angle, one angle, so angle A, and its opposite side length, length A. So this too will give you unknown pairs. And this is also is one of the required conditions in order for us to use a sine law. Okay, in order for us to use sine law to solve for the triangle, we must have unknown pairs. Okay, so the angle and its opposite side length, and plus one other length. Okay, so from this, I don't even have to draw my triangle first, but to determine the H, I know by following this formula, all I have to do is take the length B, 48, times the sine of a given angle, sine 30. So my answer is 24. Okay, when you do that from your calculator, and always make sure that you're on the degree mode. Okay, well, in that case, when H is equal to 24, which is the same length as the A, so now I know that this must be a right angle triangle because the A is the same as the height. Okay, so this is the case 1. Okay, now the case 2 on the acute triangle is when the A is less than the H. So again, I want to go back to my draft triangles again. If you look at this triangle, and because of the right angle triangles that I have here, A just cannot be less than H because A is the hypotenuse length of this right angle triangle. So after, if you know that the case that you have when the length A is less than the length of the height, that means this is not possible, because how can you have a hypotenuse length that is shorter than the height on this right angle triangle? Okay, so if you have something like that, that means there's no such triangles exist. So what we have to do, you just don't need to do anything with it, because you cannot do anything, because you cannot just draw a triangle that with A that's less than the H. Okay, so for example, I'm going to give you an example here. Okay, this is the one of the example on the worksheets. So given triangle UVW, okay, so now we have a case where the triangle doesn't call triangle ABC anymore. So you have to be flexible in terms of labeling the triangles, okay? Given angle W, 38.7, and the length W is 10. So on my triangle, okay, so I will be drawing my usual triangle like this, long, short, and enclosed. And I will put the known pairs on here. Okay, always start from the left to the right. So this angle on the left side, this is where I'm going to put the angles of the known pairs. So W, angle W over here. And the opposite side length, 10 cm, will be right across from angle W. And the other side length V, I have to put it on top here, not down here. Okay, so I always treat this as my length B. Okay, so V will be 25, therefore the angle across from length V must be angle V. Okay, so I put a capital V here. And the remaining letter U must be the remaining angle up here. So this must be the angle U, and across from it must be the length U. Okay, so after you plot it here, then you're going to find what the height of this triangle. So the height of this triangle is when you take the 25, the length V, which is the same as my length B up here, times it by the sine of the given angle, 38.7. After you calculate this, you will see the height of this triangle is equal to 15.63. Okay, so when you have when the height is equal to 15.63, that means this is greater than the A or the W now you have. Okay, so how can your height be greater than the hypotenuse length of the 10 cm? So therefore, I can say no such triangle exists. Okay, it is impossible for us to draw a triangle that with the height that is greater than the hypotenuse length. Okay, so this will be the case 2. Now moving on to case 3. Okay, so case 3 is when the A is greater than the H, which theoretically A, the hypotenuse length, has to be greater than the height. Okay, so if you have a case like that, then for sure you will have a triangle. So this is the first one, right? But we still have to have 2 other subcases under when A is greater than H. So what are the 2 subcases? Well, the first subcases is when we have to check to see if A, this length A, the length of the known pairs is greater than or smaller than the other length B. Okay, so if A is greater than the length B, then we will end up with a triangle that looks like this. Okay, so it's not long, short anymore. So it's a short, long, and then you enclose because B is smaller than the A. Okay, so if B is smaller than the A, then you will have to draw a smaller, longer, and then you enclose. So here is the 2 different cases where I'm going to show you. Okay, so this is the B, this is the C. So then of course you're going to have the heights here as well. Okay, so for example, if you are getting a triangle ABC where the angle A is 42, A is 30, and the length B is 25. Okay, so in that case, I know that when I check for the heights of this triangle, I take the 25 times the sine of 42, and that should work out to be 16.73. And this height is less than the A. Okay, so A is greater than the height. So this is the first subcase that I'm talking about here. But because A is greater than the B, because the A is greater than the B, okay, so that's why I need to redraw this into this now because A is greater than the B. So in that case, there's only one triangle can be drawn, just like that one, okay? And then you can solve for the angle B, angle C, or the length C, okay, using sine law, no problem, okay? However, if A is less than B, okay, if A is less than B, just like what my first draft triangle looks like this, then this is the case where the ambiguous case is happening. And when A is less than B, then that is when we can draw this triangle in two different ways. Okay, so let's look at the first. Well, this is the first one. This is my triangle that I usually draw, okay, long, short, enclosed, and I have the heights there. So when you check, the height is equal to the B times the sine of this angle, and if you know that this is, the A is greater than the height, okay, so this is the first look of this, but then I want you to visualize the length A here. If you're going to put this length A going inward, if you're going to take this, moving it inward like this, okay, length A, you put it inward, then you will end up with the second diagram that looks like this, okay, and with the same length A, when you put it inward, that same length A, you're going to have a shorter length C, okay, but this vertex here, I'm going to call this a B prime. So from a B over here, now it becomes a B prime. Okay, the height is still happening outside here from the vertex C all the way to the base and form the 90-degree angle. But this angle B prime here will have an obtuse angle because this angle for sure is greater than the 90-degree. So right here. Okay, so this is becoming an obtuse triangle because it has an obtuse angle. But this one here is the acute triangle because all angle inside they're less than 90. Okay, so, or you can also look at a combine. When I combine these two into one, you can see I start with my draft triangle like this, okay? If all the condition has been satisfied, the A is greater than H, and the A is less than B. Okay, if A is less than B, then that means this A, I can put it invert like this, okay? So that becomes two triangle here. So what two triangle am I talking about? So you have first, you have a triangle ABC, okay? But after I put the length A invert, now I can have a triangles A, B prime, C. Okay,